Something is moving on Pluto. New Horizons uncovers a dwarf planet full of surprises. Who would have imagined that in one of the darkest, coldest corners of our solar system, nearly 5 billion kilometers from the warmth of the sun, something might be alive, or at least moving? On a world once thought dead, lifeless, and forgotten, scientists are now discovering geological forces so dynamic that they are fundamentally reshaping our understanding of what a planet, even a dwarf planet, can be. The stunning images and data returned by NASA's New Horizons spacecraft have turned Pluto from a blurry mystery into one of the most fascinating and active celestial bodies we've ever studied. Let's take a journey through this frozen world and uncover why Pluto might just be one of the most surprising places in the entire solar system. Before 2015, Pluto was just it. It's hard to believe, but before 2015, we had never seen a clear image of Pluto. The only pictures available were blurry, low-resolution views captured by the Hubble Space Telescope, barely showing any detail. In schoolbooks and documentaries, Pluto was usually depicted through artistic interpretations, painted with guesswork, not science. We knew it was cold, distant, and small, but we had no idea what it really looked like. So, why couldn't we see it clearly? After all, telescopes can image galaxies millions of light-years away. Why not Pluto, which is within our own solar system? Here's the truth. Pluto is incredibly dim. It doesn't produce its own light and receives only a tiny fraction of the sun's rays, far less than even Neptune. Distant galaxies emit vast amounts of light. Pluto reflects a meager, frosty shimmer, barely enough for telescopes to register. New Horizons, a mission to the edge. In January 2006, NASA launched New Horizons, a robotic space probe destined to become the first mission to fly by Pluto. Traveling at over 50,000 kilometers per hour, it took nearly a decade to reach its target, zooming past Jupiter for a gravity boost and racing toward the icy edges of the Kuiper Belt. On July 14, 2015, New Horizons made its closest approach to Pluto, coming within just 12,550 kilometers, closer than many satellites orbiting Earth. Using its suite of sensitive instruments, including LORRI, a high-resolution telescopic camera, RALPH, a color camera and infrared imaging spectrometer, ALICE, an ultraviolet imaging spectrometer. It captured images and measurements that revolutionized our understanding of Pluto. The first glimpse, Pluto's heartbeat. When the first high-resolution image of Pluto came through, scientists were stunned. They weren't looking at a barren rock. They were looking at a world with texture, contrast, and color. The most striking feature? A vast, heart-shaped region now called Tombaugh Regio, named after Clyde Tombaugh, the astronomer who discovered Pluto in 1930. The western half of the heart is known as Sputnik Planitia, a smooth plain made of nitrogen, methane, and carbon monoxide ice. The eastern half appears more rugged, ancient, and heavily cratered. This heart is not just symbolic, it is central to understanding Pluto's strange and dynamic climate, as its reflective and dark surfaces absorb sunlight differently, driving weather patterns and possibly even internal heat exchange. What's moving on Pluto? The mystery of the scaly terrain. Then came the moment that shocked planetary scientists. New Horizons captured an image showing vast, scaly, honeycomb-like patterns in the icy plains of Sputnik Planitia. At first glance, they looked like the surface of drying mud or cracked desert floors. But this is Pluto, a place where temperatures hover around minus 230 degrees Celsius, minus 382 degrees Fahrenheit. What could cause such a pattern? The answer may be as surprising as the discovery itself: convection. Yes, Pluto may be geologically active. On Earth, convective cells in hot materials like magma create movement in the mantle. On Pluto, the nitrogen ice is thick enough and just warm enough, relatively speaking, to act like a fluid, very slowly rising and sinking in a process of icy convection. What does this mean? Pluto has internal heat. Its surface is actively renewing. This region is geologically young, perhaps less than 10 million years old. In a world once assumed to be inert and frozen, something is moving, driven by energy and internal dynamics. And that changes everything. Could Pluto harbor a subsurface ocean? If Pluto has internal heat, could it also have liquid water beneath its icy crust? Some scientists now believe the answer is yes. Just like moons such as Europa and Enceladus, Pluto may have a subsurface ocean of liquid water kept warm by radioactive decay in the core, tidal forces during ancient planetary encounters, insulation from thick ice layers. This raises thrilling possibilities. While no one is claiming there's alien life on Pluto, where there is liquid water and energy, the basic ingredients for life exist. If Pluto, this tiny distant dwarf planet, can maintain an internal ocean and active geology, how many other worlds in our solar system could too? Mountains made of ice, atmospheres of methane. New Horizons also revealed mountains the size of the Rockies, reaching up to 3,500 meters high. But these are not made of stone. They're made of water ice, the only material strong enough to support such heights in Pluto's cold. Surrounding them are vast plains, massive craters, and valleys carved perhaps by ancient ice flows or erosion. Even more surprising is Pluto's atmosphere. Despite its distance from the Sun, Pluto has a tenuous but complex atmosphere, primarily composed of nitrogen, with traces of methane and carbon monoxide. This atmosphere creates hazy layers reaching up to 160 kilometers above the surface. Might support seasonal weather cycles. Could allow ice to sublimate and recondense, creating snowfall. Yes, it may snow on Pluto. The side facing away, a shadowed beauty. As New Horizons passed Pluto and looked back, it took one of its most iconic photos. Pluto in silhouette, backlit by the sun, revealing a glowing halo of atmospheric haze and silhouetted terrain. It was hauntingly beautiful, a stark reminder of how little we had known and how much there still is to discover. This image revealed multiple layers of haze in the atmosphere, evidence of weather cycles. A side of Pluto never seen before, now detailed in dazzling clarity. Even the dark side of Pluto is more alive and mysterious than anyone had imagined. A dwarf planet no longer dull. When Pluto was demoted to dwarf planet status in 2006, many people were disappointed. Thousands of children wrote to NASA pleading to restore Pluto's planet title. But Pluto's status has nothing to do with size. It has to do with character. And in that regard, Pluto has exceeded all expectations. Since New Horizons, Pluto has gained the respect of the scientific community not just as an object of interest, but as a living world, with geology, weather, and possibly even an ocean beneath its crust. What does this mean for the solar system? Pluto's revelations shake the foundation of our assumptions about planetary bodies. For decades, astronomers believed only large, inner planets and moons could sustain geological activity. Now we know. Small, icy worlds can have internal heat. Dwarf planets may have dynamic surfaces. The Kuiper Belt is not a frozen graveyard. It may be a cradle of activity. Other objects like Eris, Makemake, Haumea, and even distant Sedna may hide similar secrets. The age of exploring icy outer worlds has only just begun. The legacy of New Horizons. The New Horizons mission didn't just give us pictures. It gave us perspective. It proved that even at the edge of the solar system, there is wonder, motion, and change. The data collected by New Horizons took over a year to fully transmit to Earth, highlighting just how massive and rich the observations were. And Pluto? It captured our imagination. From the heart-shaped Tombaugh Regio to the honeycomb ice plains of Sputnik Planitia, to the shimmering haze of its twilight atmosphere, Pluto is alive in ways we never dreamed possible. Conclusion: the frozen frontier awakens. Pluto may no longer be officially classified as a full planet, but in every other way, it has earned its place among the giants of our solar system. It has defied expectations, transformed science, and reminded us that even in the coldest corners of space, the universe is full of surprises. So, what else might be waiting out there in the dark? We've only just begun to explore.